The typical commercial airport is a busy place. There are many organizations, agencies, and individuals simultaneously performing many unique and diverse tasks. The airport fire department and its personnel are a big part of this beehive of activity. Successful day-to-day operation requires everyone at the airport to work together efficiently during both routine and emergency conditions. The Airport Certification Manual and Airport Emergency Plan will provide detailed information about the airport and the roles and responsibilities of the Airport Fire Department. Each airport has an index that identifies the size of aircraft it serves. You should know the index of your airport. Briefly, Index A includes aircraft less than 90 feet in length. Index B includes aircraft at least 90 feet in length, but less than 126 feet. Index C includes aircraft at least 126 feet, but less than 159 feet. Index D includes aircraft at least 159 feet, but less than 200 feet. And Index E includes aircraft at least 200 feet in length. In general, the longest aircraft with an average of 5 or more daily departures determines the index of an airport. Federal Aviation Regulation Part 139 requires airports that serve scheduled air carrier aircraft to meet certain operating requirements. The Airport Certification Manual, or ACM, describes how each airport satisfies those operating requirements. Each airport's ACM must be submitted to and approved by the FAA. Applicable portions of the ACM must be provided to airport personnel responsible for their implementation. ARFF personnel will have a copy of the ACM, normally in the airport fire station office. The ACM will identify who owns and operates the airport. The ACM will contain a grid map or other means of identifying key locations, areas, structures, and terrain features. The ACM also identifies the airport's system of runway and taxiway identification, marking, and lighting, as well as the airport's movement and safety areas. The ACM certifies which agency will provide rescue and firefighting services. The ACM will usually contain memoranda of agreement between the airport and organizations providing the ARFF capabilities. It is recommended that the ACM include a letter or memorandum of agreement with air traffic control for a discrete emergency frequency. The ACM also indicates the airport's index and the types and quantities of ARFF apparatus and extinguishing agents available to meet Federal Aviation Regulation Part 139 requirements. The ACM describes how hazardous cargo is handled, stored, and transported on the airport, and by whom. It also gives details about airport fueling operations. The airport is required to inspect the facilities and equipment of every airport fueling tenant every 3 consecutive months. Firefighters may help with these inspections. Federal Aviation Regulation Part 139 mandates that airport features must be inspected once during daylight hours and once during hours of darkness, immediately after an aircraft incident, and when required by unusual conditions. The ACM will normally contain a copy of the self-inspection form. Notices to airmen, or NOTAMs, will indicate the dates and times for which they apply. Current NOTAMs should be posted in the airport fire station. The ACM also addresses procedures for controlling ground vehicles in the movement area, radio communications, using light guns when radio communication is lost, snow and ice removal, wildlife hazard management, evacuation or shelter in place. The Airport Emergency Plan, or AEP, is included in the ACM, but can be a standalone document. As required by Federal Aviation Part 139, the AEP must assign emergency responsibilities, establish lines of authority and organizational relationships, indicate how response actions should be coordinated, describe how people and property will be protected in emergencies and disasters, identify response and recovery resources available within the airport or by agreement with local communities. The AEP has 4 major components. The basic plan describes the legal authority for emergency operations, general concept of operations, and general responsibilities for emergency planning and operations. Functional annexes are broad plans for the performance of specific tasks. They are unique to each airport and applicable to all emergencies. Hazard-specific sections provide additional information and instruction for specific hazards, such as bomb incidents, structural fires, and natural disasters. This information should be identified as sensitive in the AEP. Hazard-specific sections are designed to be pulled out of the AEP and used to manage emergency situations. Standard operating procedures and checklists provide detailed instructions on how to perform individual and organizational responsibilities and tasks. The AEP contains other important information that should be carried on ARFF apparatus, such as resource databases, multiple casualty incident plan, and information on the use of a discrete emergency frequency during aircraft incidents. All personnel must be familiar with and properly trained on their AEP assignments. Federal Aviation Regulation Part 139 requires that a full-scale AEP exercise, usually a realistic recreation of an emergency situation, be held at least once every 36 consecutive calendar months. Radio frequencies listed in the AEP should be tested at planned regular intervals. Telephone numbers should be tested quarterly. The AEP should also be reviewed in full at least once every 12 consecutive calendar months with representatives from all involved organizations and modified as necessary. Emergencies are complex and chaotic. It is essential to define specific roles and responsibilities well in advance of an emergency situation. Air traffic control is often the first organization aware of an emergency situation. The ATC tower often makes the initial emergency notifications to ARFF and other organizations. Other FAA personnel may take action to protect the incident scene and start the accident investigation process. Air carriers have extensive emergency duties and responsibilities under the law. Air carriers may make the required accident notifications. They can also provide information on the number of persons or hazardous cargo on board an aircraft. You should be acquainted with your local air carrier's personnel and emergency plans. Air carrier personnel should be included in your annual drill, and especially in large-scale tri-annual drills. Make sure airport management and tenants are included in your planning and training programs. Communications is usually the #1 problem at any emergency situation. Airport telephone lines and common radio frequencies can quickly become overloaded. Police, fire, and military organizations may have mobile communication units. Telephone companies can deliver mobile phone banks. The coroner or medical examiner directs and coordinates the recovery, identification, and processing of the deceased and their personal effects. The AEP will define responsibilities for triage, on-scene emergency treatment, and transportation of the injured to a medical facility. The AEP will also identify each building that will accommodate uninjured, injured, and deceased persons, and will provide contact information for all medical facilities and organizations. Saving aircraft occupants' lives is the primary objective of firefighters at a crash site. The fire department will also fight fires, stabilize incident scene hazards, and may assist with emergency medical services and recovery of the deceased. Preservation of the site is the second most important activity. Security of the accident scene is the responsibility of the airport owner until it is released by the NTSB or other official agency. A fire service officer will usually be the initial incident commander. In many instances, the ARFF department will be supplemented by a mutual aid response. Local mutual aid fire departments may have a tremendous amount of apparatus, tools, equipment, personnel, and expertise available for aircraft emergencies. ARFF units should be aware of the available off-airport resources. Additional agencies can be called on to support recovery operations, including law enforcement, the military, the Coast Guard, the Red Cross, and other agencies. Understanding the airport's physical layout, markings, policies, and communication procedures is essential for effective and safe emergency response. The Air Operations Area, or AOA, is the area inside the airport boundary where aircraft movement takes place. The AOA includes aircraft gates, ramp areas, runways, taxiways, and areas for both ground vehicles and aircraft. The AOA is divided into two primary areas, movement and non-movement. The movement area includes runways, taxiways, and safety areas. The non-movement area includes all areas inside the airport boundary area other than taxiways and runways. Aircraft always have the right-of-way over ground vehicles. The only exception is when air traffic control explicitly authorizes a ground vehicle to have right-of-way over an aircraft. A solid yellow line and a dashed yellow line together usually separate the movement area from the non-movement area. Ground vehicles and aircraft must obtain specific approval from air traffic control for entry into the movement area. If there is no air traffic control, or if it is closed, vehicles and aircraft must announce their intention to enter the movement area over the appropriate radio frequency. Taxiways can be identified by letters and numbers, or specific names. Taxiway designations are not standardized and are generally determined locally. Always use the International Phonetic Alphabet to communicate taxiway and other letter designations over the radio. taxiway location signs have yellow letters or numbers with a black background and a yellow border. When facing a location sign, the designation in the box is the taxiway the aircraft or vehicle is on. Air traffic control may refer to taxiways by their relationship to runways. Taxiways can be parallel, cross, or diagonal with respect to a runway. Where a taxiway intersects a runway, there will be a holding position marking or hold bar with 4 parallel yellow stripes extending across the entire width of the taxiway. 2 of the stripes are solid, while the other 2 are broken or dashed. The solid bars mean to stop unless directed otherwise by air traffic control. The broken bars mean free to cross and will be closest to the runway. Yellow lights, known as guard lights, may signal the locations of hold bars. Instrument landing system areas have unique hold bars. Aircraft use instrument landing systems, or ILS, when landing in inclement weather. The ILS glide slope and localizer systems have a safety zone called a critical area surrounding them. The outer boundary of the critical area has unique hold lines and will be marked with a red and white sign. ARFF apparatus in an ILS area can affect the ILS system. When the ILS system is active, do not cross ILS hold bars without clearance from air traffic control, even when the normal hold lines are ahead. Runways are paved areas designed for aircraft takeoff and landing. Runways have a white stripe on each edge and a broken white center stripe. Runways are aligned with the prevailing winds, since aircraft normally land and take off into the wind. However, an aircraft in distress may use the closest available runway. Runways are labeled numerically by compass headings, as seen from the approach end. Depending on the wind direction, either end of the runway could be the approach end. If the prevailing winds blow west to east, the runway would be oriented on the east-west axis. Aircraft moving east to west would see a compass heading of 270 degrees. Runway designations eliminate the last digit of the heading, so this is runway 27. Aircraft approaching the same runway from the opposite end would see a compass heading of 90 degrees. From that direction, the runway is called runway 9er. Parallel runways share the same compass heading but are called left or right based on their position in the approach view. For example, parallel runways at 180 degrees would be designated 18 right and 18 left. A third runway between them would be 18 center. Runway numbers are oriented so they are visible to arriving pilots. Runways have white edge lighting at 200-foot intervals for night or poor visibility operations. On runways with ILS approaches, the last 2,000 feet of runway edge lights will be amber to designate a caution zone. Runway holding position signs are always red and white and illuminated at night. The ends of most runways are also marked with green and red threshold lights, green facing the arrival direction, and red facing the takeoff direction. High-intensity white strobe lights, called runway end identification lights, identify the approaching runway threshold. Runways used by jet aircraft will have threshold markings consisting of 4 to 16 broad white stripes depending on the width of the runway. Part of the runway may be unavailable for aircraft landings, but available for takeoff or rollout when landing in the opposite direction. In this case, the runway is said to have a displaced threshold. A displaced threshold is marked by a solid white threshold bar across the runway that shows where the landing portion of the runway begins. The area behind the threshold bar may be used for takeoff or rollout when landing from the opposite direction. If an area behind the threshold bar can be used for taxiing purposes, it will have a yellow taxiway center line down the middle with yellow arrowheads pointing at the threshold bar. Areas used to dissipate jet blast for overruns during aborted takeoffs will be marked with yellow chevrons. Aircraft cannot use these areas in any other circumstances. An X painted on a runway or marked in lights means the runway is closed. Runway distance remaining signs are black with white numerical inscriptions. The number on the sign indicates the total runway landing distance remaining in thousands of feet. These signs may be located on one or both sides of the runway. The runway safety area is an area surrounding a runway capable of supporting aircraft under dry conditions without structural damage to aircraft or injury to passengers. Runway safety areas often extend up to 1,000 feet beyond each end of the runway and may be up to 500 feet wide. Except for fixed objects required for airport operations, no object or vehicle may be left in the safety area when the runway is open. Movement areas may have large paved areas for staging emergency apparatus or parking aircraft during an emergency. Most airports also have free travel areas, such as perimeter roads and service roads, where vehicles can move independent of air traffic control. ramps and aprons are used to park and service aircraft. A gate is a terminal area where air carrier aircraft park to plane and deplane passengers. Exercise extreme caution and care when operating around ramps, aprons, and gates. Large aircraft parking areas will often have red and white envelope lines on the tarmac to indicate the area the aircraft will use. Do not park inside an envelope or behind aircraft at the gate. Check with ramp personnel to find a safe place to park, and be sure to leave someone with a parked vehicle to move it if necessary. All vehicles must yield if anti-collision lights are on, which means the engines are running or the aircraft is being moved. The airspace around every major metropolitan area in the country is crowded with aircraft flying, landing, and taking off. Statistics show that 88% of aviation incidents occur during takeoff and landing, which together make up only 7% of total flight time. Air traffic control is responsible for coordinating, sequencing, and separating the movement of aircraft during takeoff, flight, and landing. When an aircraft is at a certain altitude, location, or distance from the airport, the pilot will switch to the air traffic control tower frequency for their final destination.
Air Wisconsin 3750, Richmond Tower, state nature emergency.
In an emergency, any aircraft may attempt an emergency landing at the nearest accommodating airport. An aircraft incident can occur at any time or place. The traffic pattern is the prescribed series of movements for aircraft landing or departing from an airport. It is important for airport firefighters who may be waiting in a standby position for an in-flight emergency to be aware of traffic pattern movements. A typical traffic pattern has the following components: the upwind leg, the crosswind leg, the downwind leg, the base leg, and final approach, also known as final. In an emergency, an aircraft may not fly a traffic pattern, but rather a straight-in or modified approach. An aircraft in an emergency situation may force other aircraft in traffic patterns to perform go-around or missed approach maneuvers instead of their planned landing approaches. Airports serving air carrier operations will have a Security Identification Display Area, or SIDA. Personnel in this area must have an appropriate airport badge or an escort. You should investigate anyone without an appropriate badge visible. If necessary, escort the person out of the SIDA or notify security. Badges or card keys may be needed to access doors and gates to certain airport structures or the AOA. Some fences may have breakaway or knockdown posts that ARFF vehicles can carefully drive over. Use caution to avoid damaging bumper turrets. Every airport has unique features, from large bodies of water to nearby highways, agricultural areas, or wildlife preserves. Elevated obstructions such as water towers, smokestacks, cranes, and power lines are sometimes painted in red and white striping and marked with red flashing lights or white strobe lights. You should be thoroughly familiar with the airport environment, layout, and any special natural or structural features. Referring to a map can waste valuable time. You should also be aware of the current and projected conditions and activities of the airport, including weather and construction projects. Many airports present structural fire protection problems similar to a small city. Hangars, hotels, restaurants, air traffic control towers, cargo facilities, parking garages, and offices will have their own emergencies and may be affected by an aircraft emergency. Most airports also have terminal areas that represent a tremendous life hazard, especially when passengers exit the terminal to board or deplane. ARFF vehicles should carry appropriate airport maps and structural pre-fire plans. Maps should be easy to read and indicate every emergency response-related aspect of the airport. Water sources are an important airport feature. Hydrants are usually located near airport structures and perimeter roads. Most airports do not have hydrants in movement areas. Fueling operations are the #1 fire prevention consideration at airports. Fire prevention measures focus on preventing spillage and eliminating or controlling potential ignition sources. Fuel is loaded onto aircraft by one of 3 methods. One method uses underground piping and underground fuel hydrants in aircraft ramp parking areas. A fuel hydrant truck regulates the flow of fuel into the aircraft. A second method is to use fueling islands. A third and most common fueling method is by tanker truck. To transfer fuel, truck drivers must hold open a dead man device, which will shut down the fueling operation if released. Fuel trucks must also have emergency shutdown switches and fire extinguishers. Larger aircraft receive fuel through single-point fueling connections under the wing or in the fuselage. In addition, almost all aircraft have over-the-wing fueling locations that fill directly into individual tanks. Fire extinguishers are required on aircraft service ramps, fuel loading racks, and fueling vehicles.